You first come across functions when you think about number machines. So we have an input, and then we put it into the machine. So it might say times by 3, then minus 2, and then we get our output. Functions is basically saying this, except we have x as our input. So we start with x, we times that by 3, and then we minus 2. This is our output, and that's our function of x. In this case here, we don't have that, but the principle is still the same. Now, when we've got an inverse function, we're going the opposite way. So we're going from our output, our function of x, we're adding 2, then dividing by 3. So we go in the opposite direction and do the opposite of those operations. So if we're cube rooting x, the opposite of that must be cubing. Cubing, that undoes a cube root. So our inverse function must be equal to x cubed. There's a variety of ways of working out an inverse function. The inverse basically means that the y and the x have switched over. So if the y is equal to a function of x, then we could replace it as y equals the cube root of x. But if we switch x and y, we get that x is equal to the cube root of y. If to make y the subject, we have to cube. We have to undo this cube root. Either way, we get that y is equal to this, and y is equal to the inverse function. Now to plot this onto the graph, and we have to do it from minus 2 up to 2, making sure we don't go below that or above that. Table mode, we've discussed how to use that already, so if you're up and ready with that, put it straight in and you will get your results. Otherwise, 0 cubed is 0, 1 cubed is 1, 2 cubed is 2 times 2, which is 4, times by 2 again, we get 8. And then going down the other way, minus 1 cubed. Now, sometimes minus 1 cubed throws people off, so I'd probably use a calculator for this, making sure you're using brackets. That's, of course, if you haven't used table mode already. Minus 1 times minus 1 gives you a positive because it's double negative, and then times by negative 1 again, that's going to give us minus 1. And then we're going to get minus 8 down here. So plotted on all the points on the graph, now we just need to join it with a curve. This is a cubic, we call it. But again, we just want to make sure we go through all of these points if we can. It doesn't matter if it's like a little wobble like I did there. Don't accept that, that's fine. It's in the right shape and it's going through the points, so that's all good. Going back to our number machine idea, we have function of x. That basically means you take your input and you perform the sine function on it. And then you get your output. And then the function of g, that's basically saying that you take your input and you add 90 to that. And that gives you your output. Now when we've got a composite function like this is basically saying that you do one function and then you put the result inside the other. So when we have fg of x, we can think about that as function g of x, like so. And that we put the function g of x inside function f. So you must have done g of x first. Remember when we were doing with functions and you put something like f2, that's basically saying that x is equal to 2. So you put 2 into the function and we get sine of 2. Not a good example, should have done something like 90 or 180 there, but I suppose you still get the same value out of there. So this is saying put function g of x inside function f. In function f, x should be replaced with x plus 90. So we get that our composite function is sine of x plus 90. Thinking about it in terms of the machines, we're doing function g first, so we're adding 90. We're taking this output, putting it in as our input on this one, and then we're providing the sine on that. That's basically what we did here. And now we just need to put in our values. Table mode, we can just put in 0, 90, 180, 270, and 360, just our key points, and plot these on. And we should get something very similar to, actually identical, to the cosine curve. That's basically what cosine is. It's just sine add 90, because it's just 90 degrees out of phase of it. But if in doubt, we can just do the calculations one by one. So x plus 90. X at this point is equal to 0. If we add 90 to that, we get 90, sine of 90, we do get 1. Add 90, we get sine of 180, sine of 270. So you can see how this is just shifted across from the sine curve.